I'm going to answer the question, where does the rule for integration by parts come from? You know, it's always nice to be able to use a rule, but it's nicer to know where it comes from. So this is the rule that most calculus teachers give their students. And we want to start in deriving this by realizing that integration by parts is the reverse of the product rule of derivatives. So how do I derive this? I start with the product rule and I do the reverse of it, in a manner of speaking. So I'm going to take the derivative with respect to x of a product of two functions, f of x, g of x. Now this is something we should know at this point. So the derivative of that product is f prime of x, g of x, plus g prime of x, f of x. Okay. Now, if I want to reverse a derivative, I integrate it. So I'm going to integrate both sides of this equation, which is exactly the reverse, kind of like logarithms and exponentials. But I am going to integrate it with respect to dx because that's the independent variable here. So I keep writing, integrate this piece, and integrate this piece. Okay. On the left-hand side, I see I'm integrating a derivative, so that will leave me with just the integrand itself. So over here I have f of x, g of x. The other side, there isn't a whole lot I can do with, but we're going to have a discussion about all the different possibilities that can happen once I get this rewritten. Everything's the same on the right-hand side. Now, in any equation in mathematics, anytime you have three pieces, two of them are known and one of them is unknown, you can always solve for the one that is unknown. So in this case, if I know f and g, and I can integrate f prime g of x dx, then I can automatically use those numbers to find what this antiderivative is. And similarly, if I know f and g, and I can integrate simply g prime f of x dx, then I can solve for this guy independently. That's really kind of nice. It's like saying x plus 2 equals 4. That means I can find x real easily by subtracting 2 from both sides. It's the exact same concept, exactly the same. So what we do is we just say, okay, I'm going to solve for this integrand, just kind of randomly. I'm not sure why they chose. And then I come up with the formula for integration by parts. So here we go. If I solve for this piece, on the left-hand side, I'm going to place it, g prime of f of x dx. And that means that I'm actually going to subtract this piece from both sides. So on the right-hand side, that's going to leave me with f of x, g of x, minus the integral of f prime of x, g of x dx. Well, and then you say to yourself, hey, you know, that doesn't look anything like this. Well, it does if we do a little bit of substitution. So we're going to let u equal f of x. We're going to let v equal g of x. We're going to let du equal f prime of x dx, just like in integrating by substitution. And then we're going to let dv equal g prime of x dx. Okay, and then I'm going to make my substitutions. So let's see, let's start over here. G prime of x dx, why, that's dv. And f of x is u. So the integral of u dv equals f of u is u and g is v. uv minus the integral of, let's see, f prime dx is du. And g of x is v. Now, there's our familiar formula. u dv is equal to uv minus the integral of v du. And hence we have derived the rule for integration by parts.